All right, gang. So I just got done whining a little bit about this issue that I'm dealing with on how I'm trying to beat my brother's lasagna recipe and just top it with something unique. So I'm trying to make this salsa recipe that's all homegrown and is just great stuff. But I'm running into this issue of being able to grow peppers in my garden. So what I want to do is figure out how we can kind of fix this issue using science. So today what I want to do is focus a little bit on this idea of asking scientific questions. So let's take a look at this question that I have of why can't I get chili peppers to grow in my garden? And I think what's important to understand here is that science is trying to explain how the world works. And there's certain kinds of questions that can be answered by science and certain kinds that can't. Often what happens with scientists is we look at something that we don't understand, we ask, well, why is that? And then set up experiments that will help us understand better about the factors that influence whatever problem it is we're running into. In this case, the problem that we're running into is for some reason I can get tomatoes to grow, I can get onions and all of those other things that you would normally put in salsa to grow in my garden, but I can't get the peppers to grow. So let's take a look at this problem through the lens of scientific questions. So like I mentioned before, not every single kind of question can be answered by science, and that's okay. What I want to do is kind of show you the differences between scientific questions and non-scientific questions. So hopefully you can go and differentiate between those two things. So let's look at the scientific questions first. Okay, so when we look at this, scientific questions, they have a few characteristics. Scientific questions tend to be specific and testable. Okay, and let me show you what that means. Whoops. Now, if we look at the scientific question of why won't chili peppers grow in my garden, the reason we would consider that a scientific question is because it's specific, okay? We know exactly what it is we're trying to find. I've got a problem with chili peppers that happen to be growing in this patch of dirt in my garden. And figuring out what the heck is going on here. Also, I can test this. I can do experiments to figure out what factors are affecting my garden's ability to grow those peppers. So I can go and I can measure things like the amount of water that it gets, the amount of sunlight that it gets, different kind of nutrients that are in the ground and things like that. Those are all things that I can measure that will tell me what factors are affecting chili peppers' ability to grow in my garden and which factors aren't. However, if we look at the other side of this, the non-scientific questions, okay, these are important questions, but they aren't questions that science can answer. So, for example, non-scientific questions tend to be vague, and I don't know if vague is the right word for that. Let's say they tend to be open-ended. So, for example, if I were to say, what's wrong with my garden? Okay, that's a legitimate question, but it's not really something that science can answer because it's so open-ended. There could be a lot of things that are wrong with my garden, but it's not specific enough to allow me to be able to test those things. Also, we want to avoid questions that are opinion-based. So when we talk about opinion-based, we're talking about questions that different people would give different answers to. So for example, if I were to say that raisin is small, okay, we could say, you know what, if we're talking about small or size, is that small compared to an elephant or small compared to an ant? If you were to ask people who is the greatest basketball player of all times, some people get pretty riled up about this. They'd say Michael Jordan. Some people would say Wilt Chamberlain. Some people would say Bill Russell. Some people would say LeBron James. Okay, so those are all opinion questions. So whenever you see words like a lot or a little, big, small, best, worst, things like that, those are kind of red flags that those are opinion questions. So if I were to ask the question, why are peppers gross? Well, that's not really going to be something that we can test scientifically, because some people think that peppers are gross, other people absolutely love them. So we've got to figure out how to get those questions from being opinion to being more something that we can specifically test. And that is the last thing, is that questions that are untestable, things that involve things that we can't measure, those aren't questions that can be answered by science. So for example, if I were to look at a work of art, look at a beautiful painting and say, what is the meaning of this painting? Well, that is something very deep, something that you would ponder, but it's not something that could be answered by science. If I were to say, what is the meaning of life? Very good question. Not something that science could answer. If I were doing this in terms of like my garden, if I were to say, I think the reason that my peppers won't grow is because my garden is cursed. Okay, it's something put a hex on it, and it's cursed, and that's why it won't grow. Well, that might be the case, but it's not something that we could measure. We can't test cursedness. Is that a word? But anyways, you get the idea that it has to be something that we can observe and measure, and not everything is that way. So here's what I'd like you to do. I've given you a bunch of scientific questions and non-scientific questions about my garden. What I want you to do now is come up with your own questions. So after you're done taking these notes, I want you to come up with one scientific question and one non-scientific question about my garden, and then be ready to share those with the rest of the class.